Mm. Okay, so this is my title, group structure, and as you see, recycling is just one of the three main group, and battery recycling solution is one of the recycling group. And yeah, because we focus on the EV, I think this is a little bit different with Anwar mentioned for the portable battery. So we try to recycle the valuable elements like nickel, cobalt, and lithium, and copper. So and today is for the outline. Probably I will focus on three topics. And the first topic would be the warehouse because we need storage and logistics for both spent battery and black mass. And the second topic will be fire, and the third one would be explosion. So yeah, because I think because before I didn't have any industry background before I joined Umicore, so I also have a strong background for fire explosion safety background in academic. So this is the first time for me. So I try to build a bridge between the science and the engineering. Yeah. Okay. And then those will be the topic and talk about the thermal runaway, but not for detail or for show the results, but just an overview for such topic, focus on fire and explosion during the recycling batteries. And also I mentioned a little bit about the black mass. So this one probably I just can fast. Yeah, I think some part already because last month I visited RISE, so some results or my presentation already presented there. So if you were there, so yeah, please be patient. And I also add something new here. So as you see, is the markets, except for the portable, I think for both the stationary and the mobility applications, markets growing up very fast. Yeah, especially for EV or the ESS, yeah, the storage, energy storage station. But as you see, the incidents, accidents also increase very fast. So unsafety is everywhere during the full life cycle of the battery from the production phase, use phase, and also the end of life phase. So anyway, the logistics or storage are necessary for all the phases. And my focus is on the EOL phase. So this part, I think Anwar already mentioned about this for the process of recycling. Yeah, we try to close the loop for circular economy and also for the better yeah, the circular economy. And actually, I googled here just the only 5, but this number probably not true. And I discussed already with Chen. We don't know exactly how much percentage about this, but because this number can be wrong. But the challenge for industry or the companies, yeah, we try to build more the factory. Everybody knows that's good for environment and also for the economy. But yeah, if you build a factory, that's fine, but not in my backyard. Yeah, otherwise you will get a lot of yeah, political things or a lot of protesters. Yeah, and this and those are the potential process. I think for Anwar, probably your company don't have the competence of pyrometallurgy, but at Umicore we have a strong background of this. So yeah, probably your it directly go to hydro, so you need to make or shredding to black mass. But before before I think our company just through the full battery in the smelter, and then afterwards we refine through the hydrometallurgy. And my focus is pre-metallurgy, so including deactivation or discharge, or dismantling, and thermal presettlement, like pyrolysis and shredding. Another colleague work on this topic. And in my opinion, I think pyrolysis is also a kind of thermal runaway, but on purpose. Yeah, and also for each process, the process safety is also important. But currently, my focus is not on this topic, but on the storage and logistics. So yeah, as you see, for the warehouse, yeah, this picture shows the accident beginning of this year in middle of France. Yeah, actually, at the beginning of last year, France also has had a such big accident for their warehouse. A story, the lot of spent battery or the new batteries. And for the consequence, will lead to the life and property losses, and also the pollution for environmental, and also the health issues. So in fact, currently our company don't have our own warehouse. So this is the warehouse we rent from external partners, and those are the containers. So, but already I think Anwar already shows something similar like this. So we try to we need to optimize the storage, because you see there are a lot of problems, and you see there's low standards for the packing. Yeah, there are a lot of types, like the drums, like steel, plastic, and wood or the cotton box. And actually, a battery is not new, and warehouse is also not new. But the spent battery, especially in the warehouse, is new. And spent battery, the SOC, the state of charge of the spent battery, can vary in a wide range. Yeah, like some of them are fully discharged, but some of them are not discharged. But probably, but in average, probably still have 30% SOC. And also the state of health is not known. But for the labeling or the sorting or second use is not our focus. So we just recycle it. And as you see, for this warehouse, the height is quite high, and if you see the sprinkler system on the ceiling, I don't know about the efficiency in case of fire. And there's low fire detection system. Except for the spent batteries, there are other like combustible materials, like the containers, and also there is another case. How about black mass? In the future, probably black mass will be stored together with spent battery. But in that case, do we need a compartment, especially for black mass or not? That's also a topic. So yeah, because this is the huge compartment for the warehouse. So for the current European Code 112 would be a lot applied in our case. So we need to do some simulations to save the cost. Yeah, because nobody is going to perform the full tests for the full warehouse for such tests. That's expensive and disaster. We try to avoid. So we need to do some simulations. And my role is try to build a bridge before the engineering and the science. Because for fire engineering, conservative sometimes is always good, but for fire science, we need a correct. And currently, we have a master student from Ghent University, cooperated with Professor Parmesi and work on this topic. So yeah, but Yeah, here just show some results from literature, and as you see, the heat release rate will be very important parameters, and here we get the results of the heat release rate from the single cell, and then we get a numeric. But the typical thing here is it's very difficult to evaluate the ignition delay before the fire or ignition or thermal runaway. So that's the reason here you see it's quite overestimate. Yeah, for example, even the battery is fully discharged, but in 30 minutes you see smoke already spreads already. But this is not true. So we need to improve and optimize the parameters. So we need to validate the model with the experimental data from the FM Global or from RISE, or we can perform some tests ourselves as well. And here shows the example from FM Global for the battery pack. Without, there are two scenarios, without sprinkler and with sprinkler. And I'm not going to talk the details here. Anyway, there are a lot of input parameters we can compare. For example, for the on-state and the peak temperature and the heat release rate, and also a lot of parameters we need to do some like sensitivity analysis. Okay, let's move to the thermal runaway. For the thermal runaway, because the battery itself is not inherent safety, so as you can see here, the cathode material, anode material, those are combustible, but not for cathode. But cathode material, in case of thermal runaway, will generate some oxygen. This will support the combustion of the flammable or combustible material, especially for the electrolyte and the separator, and also even SEI layer. So the thermal runaway will release a lot of heat and smokes, including flammable, toxic, and corrosive gases. Yeah, except for the gas, I think we are overlooked the vapors. The vapors can condensate during our preliminary tests, and also some solid particles. So it's quite, it's much more complicated than cocktail. So I'll talk about more details later. So it's kind of a hybrid mixture. It's not just pure like gas or a vapor or dust. And for battery fire extinguishing, the strategy is try to stop the fire or thermal propagation, not the thermal runaway, because you can see the thermal runaway of the battery, we try to extinguish it. Even we throw in the water, the reaction continues. Yeah, but there's no fire because even the vapors or the smokes here are flammable, but they are diluted in the air. And also there's no ignition source. So that's a strategy we try to break the fire triangle. Yeah, the cooling effect, this is important to remove the heat source and also the chemical reaction inhibition. So that's related to the like some extinguishing agent like F500, and also lower the oxygen consumption. Yeah, this shows example for liquid nitrogen to cool the battery and remove the heat. But there's a big challenge because last week, if you read the news, the Gateway energy storage site in California, the Alta Mesa, get a huge fire. I think this storage site used to be the largest energy storage in the world until 2021 or something like that. The big fire is difficult to extinguish, but for the test, like you try to publish a paper, and that's quite easy if you do small scale tests. Yeah, here we compared some different extinguishing agents like water mist and also F500. Yeah, and another issue about extinguishing is so far there's low standard because for all the commercial extinguishing agents, they say their products is the best always, but we don't know which one is the best. And also for batteries, difficult because it is quite challenge. Will suffer the regulation. Yeah, here shows an example and. Yeah, even the fire was extinguished, but you just leave it over there and for a while, and the temperature continue increase to reach the second fire, and that's called reignition. And another reason is another challenge I think is for the if we use water or water mist or sprinkler system to extinguish fire, generate a lot of water, wastewater, and that's also we need to handle the water. Otherwise, those water, if you directly discharge to the soil, river will pollute the soil and the water. And PFAS is also a new topic. And for environmental issues, and another challenge is about exposure because battery fire, as mentioned before, probably I go back to another slides. Yeah, because according to by statistics, 90% will suffer a battery fire. Only around 10% will suffer explosion. So, for example, in 5 years ago, in our company, the plant, yeah, as you can see the video here, the battery fire can stop from exploding because the container is completely confined, and this is a subsequent fire after explosion. Yeah, but fortunately, nobody was injured because yeah, because the evacuation. If you heard something, it's just run away. Start here takes up around 90%, but for the explosion, it's much lower the possibility. So there's a transition between the fire and explosion. So if you look at the fire triangle and the explosion pentagon, and here shows an example of the off gas. But yeah, also for our own tests, we try to analyze the gas composition and the concentration of the off gas. So the main components will be CO2 and CH4 hydrogen and C2H4. But there are other flammable materials. For example, for electrolyte, if you look at their flash point and a lower flammability or explosion limit is very low, and they are easily to condense. So they will contribute the fire explosion. And also, especially for NMC battery, after the thermal runaway, you see a lot of castro material or the graphite. They emit together with off gas, but not the case for FP battery. So that means the battery chemistry plays an important role for the off gas or the products of the reaction of thermal runaway. And finally, we go to black mass. Yeah, for this one, and we also get some sample because currently Umicore we don't produce or generate the black mass by ourselves. We just receive some from the market from other partners, and we choose several samples. Yeah, and the results shows that the smoldering fire initiation from the auto-ignition or self-heating risk is much higher than explosion. Because according to the standard test procedure, under 2 kilojoule ignition condition, there's no explosion at all. Yeah, but I think Chen will talk more detail about this in their experiments at under higher ignition energy get explosion. So just make a short summary here. First thing is there's a bridge between the science and the engineering, or the academic and the industry. So, and the second is the process safety, yeah, like the shredding or charge discharge. Yes, please. That's also very important as the storage or logistics, and it's much more complicated. This is case by case. Yeah, for example, like a discharge, because for example, for black mass, black mass, the shredding is after the pyrolysis or not, or discharged or not. That's also make a big difference. And fire and explosion can transit each other under a certain condition. Another thing is hybrid mixture explosion, and the smoldering fire of black mass overlooked. And of course, there's other issues like health or environmental issues that should be considered during the fire and explosion separation. And the last is there's still a big challenge for the super large scale battery fire separation. So that's the reason we need to work together from both for academic and industry partners. All right, thank you very much. And here's my email. And also, actually, before I did some work for smoldering fire and both dust explosion and hybrid mixture explosion. So if you want to get more information, you can look at my Google Scholar or add me or connect on LinkedIn for more information. All right, thank you very much.